Hey Tops, let's talk about speed and velocity. So, one thing to note is that they are different, but they both describe how fast an object travels. So, you can calculate speed by using distance divided by time. However, to fully describe velocity, we also need to know not just how fast, but we also need to know what direction it moves. So, remember when we talked about distance and displacement, and it said that, or we said that displacement was a vector. Well, velocity is the vector form of speed. So velocity is speed in a given direction. It has magnitude, which is the size of the speed or the size of the velocity, and then it has direction. All right, so the speedometer in your car gives you readings that are called instantaneous speeds, and that tells you exactly how fast you're going at that instant. Whereas when you do distance divided by time, you're actually finding an average speed. So the units for speed and velocity are both the same, and they can be any units of distance over any units of time, such as miles per hour, kilometers per hour, centimeters per day, light years per century. And most of all, we will use meters per second in class. Those are the SI units. So the equation that we will look at, and we'll look at it again here in just a minute, but speed is calculated by the total distance covered divided by the time. Now, when we think about velocity, we're going to be using displacement divided by time. So remember how distance and displacement can be different, whereas one could be positive, one could be negative, or they could be very different numbers. So in this case, if we're looking at speed, in this example, it says a distance of 240 kilometers during a time of 4 hours has an average speed of 60 kilometers per hour. We would do 240 divided by that 4 hours to get our units. And one thing that's important is when you do your unit analysis, if the units in your answer match the units that you should get, then you know you have the right answer. For example, we know that we are dividing kilometers per hour, and if we just leave that in the equation itself, then our answer will come out kilometers per hour, which is what we need to represent speed. Now, velocity is different again in the sense that it has direction. So if a car is moving in a circle, then it could have constant speed, meaning like I could go around a circular track at 20 miles per hour, but that's not considered a constant velocity because I'm always changing direction. So even if you're just changing one part of your direction, then that changed your velocity. All right, change in position over time, or displacement divided by time. So notice if you're moving to the right, you're going to have a positive displacement. If you're moving to the left, you're going to have a negative displacement. So if you're moving to the right, you have a positive velocity. To the left is a negative velocity. So you guys will be working on graphs later on this week of your own motion, and your graph will look something like this. So when you take time and position data for an object moving with a constant speed, you're going to get a linear graph. This means that we have, we're going 50 meters in 10 seconds, 50 meters in another 10 seconds, and then another 50 meters in the next 10 seconds. So notice I'm covering the same amount of displacement, the same change in position for equal time intervals. That means I'm moving at a constant speed. When this slope is linear, when it is not changing, meaning it's not getting more steep, it's not curving up, or it's not getting less steep, it's not leveling out, then that means you're moving at a constant velocity. So this would be a constant velocity to the right. And if I were to do distance divided by time for any point on this graph, I could do 50 over 10, 100 over 20. To find the slope, you go rise over run. That gives you a speed, in this case, of 5 meters per second. Okay, and this is This looks a bit like repeat there. Let me just move myself. So the data shows the runner took 10 seconds. Okay, I just went over all of that. All right, so the steepness of a line is measured by finding its slope. Remember, slope is rise over run. So here we have two runners, runner A and runner B, and we can see that runner A is actually moving much faster. Maybe not much faster, but runner A is moving faster than runner B because the position graph is steeper, and the slope or the steepness will represent the velocity. So we see that runner B's speed is 4 meters per second. We pick 2 points on our graph. Okay, so I'm going to choose this ending point. So we go 600 meters. Remember, velocity is displacement over time. So I'm going to say we went 600 meters in 150 seconds. When we do that, we get 4 meters per second. We could also say 100 over 25. And guess what? We still get 4 meters per second. So that indicates that when it's linear, you have a constant speed. So the slope of the line is the ratio of rise over run. And you've looked at that in your math class. Now, to calculate distance, if we were to take a velocity graph and kind of work backwards, so notice this has speed on the y-axis. So when we look at our speed or velocity graph, this shows a constant velocity. It's not changing. It's 5 here, 5, 5, 5. The velocity isn't changing. Well, if I take 5 meters per second multiplied by 60 seconds, then if we look at our units, seconds cancels with seconds, so we would get 300 meters, and meters happens to be a unit of distance. So if I'm wanting to solve for distance, I can look at the area under the graph, or I can simply do speed times time, velocity times time. One thing that's important to note is that with a position and time graph, when you have a constant velocity, your speed or velocity graphs will always be flat lines. All right, so you might want to take just a moment and pause this to write all of these equations down. There's really just one main equation, and that is velocity is displacement divided by time. But of course, we've seen a triangle like this before when we looked at density. This triangle sort of helps us keep all of our ratios organized. So this solves for velocity, this solves for time, and this solves for displacement. And that's really all you need for velocity. So let me know if you have any questions.